Hi guys, it's Rafi here, and in this video we are going to take our first step toward deploying a monitoring stack and provide observability to our clusters. The main question here is, why do we need monitoring stack after all? Well, I think the worst thing could ever happen to DevOps team is somebody else from another department, or it can be even the customers, come to DevOps team and say, oh, something is not working. So for example, developers come to you and say, CI/CD pipeline is not working, or it has some delays, or something bad happened to customer is not able to reach to the application we provided for them. And that's the worst thing could ever happen. To avoid such a situation, we need to have an eye in our infrastructure and the whole ecosystem that our components are living in to detect those problems and start solving them before somebody else starts complaining about it. So the tool that we are going to use as a core concept, as a core component of our monitoring stack is Prometheus. Basically, Prometheus is an open source time series database which is capable to connect the metrics and data based on the timestamps. This is the thing that we need, right? Because we need to have all the metrics in different points in times. And because of that, this tool can satisfy us. But the next question is, what is time series database after all? Well, time series database is a database which is designed in a way that collect some data based on the timestamps and then design in a way that provide some features like fast query response over time, given timestamp. Also, Prometheus is scalable and reliable, and this is the core concept that we are going to use in our monitoring stack. Let's go through the documentation of Prometheus itself to get more familiar with the architecture it has and the components in between. Well, the core part of Prometheus is Prometheus server, and as you can see, the time series database and the HTTP server is available here. HTTP server basically is a way that we can reach to the Prometheus itself and send queries and get replies back over the HTTP protocol. And also it needs some storage, no matter where it is, even either you are using it in the cloud environment or installing in the bare metal, there should be a persistent storage that can host the time series database itself. It has another component, namely Alert Manager. Basically, Alert Manager is responsible to consider the rules we define for Prometheus and send alerts upon the rules that we created. And then there is another component here, Push Gateways. Let's see what it is actually. Prometheus itself is working in pull-based mechanism. So the story is like, we define some targets in the Prometheus configuration, and Prometheus is responsible to send requests to those targets, retrieve the metrics, right? But we have some scenarios that we cannot reach to the target directly. Just imagine the situation that the targets are behind a firewall, or it can be behind a net. And in that case, we cannot reach them directly. In that case, we should leverage another concept, namely exporters. And exporters are basically responsible to get the data from the targets and push it to the push gateway, and then Prometheus can simply just retrieve all the data, all the metrics from the push gateway. And this is all the main components available here. Another amazing feature that Prometheus provides for us is it can easily integrate it with the Kubernetes and start interacting with Kubernetes service discovery. What does that mean? That means basically Prometheus, with the correct configuration, is responsible to fetch all the data related to application and the services available inside the Kubernetes cluster and know them automatically. So in case that you are deploying new applications or some application is scaled up, you don't need to change the Prometheus configuration. The only thing you need to do is once configure Prometheus in a way that they can connect to the Kubernetes service discovery, and from then it's able to detect all the new applications like Kubernetes, start interacting with them and fetch the metrics from them. Now that we know the architecture of Prometheus, let's dive into the deployment of Prometheus inside the cluster itself. Going back to the VS Code, Let's see what is our directory structure right now. Okay, as you can remember in previous videos, when we create our infrastructure, we use this directory structure as well. We created an infra, and inside the infra we have CI/CD, and inside the CI/CD we have Terraform, which is basically a directory that is responsible to host all the Terraform codes responsible to create our infrastructure. And then we have some tools. For tools, we have Nginx Ingress, which is simply a directory contains a Helm chart for Nginx, and we applied it into the Kubernetes cluster because we need to access the Jenkins and Argo CD and other components available inside the cluster. And then for the tools, we have CI/CD, and inside CI/CD we have Argo CD and Jenkins deployment files. Now what we should do is basically create another directory inside tools, and let's name it as Prometheus. And inside the Prometheus, let's create the deployment file itself. And see what are the configurations we have in there. So this is the basic configuration for Prometheus. You can find this file inside the Git repository I provided. The link is down here. You can see it in the description as well. And the first thing we need to define here is the configuration for Prometheus. Prometheus should know about what are the targets and what are the scrape intervals. So to do that, we need a config map, and then this config map will be mounted inside /etc/prometheus/prometheus.yam file. Basically, this is the file Prometheus is looking into to see the configurations. And then we have persistent volume claim, and basically that's because we want all the data in the Prometheus be persistent in our cluster. We don't want to lose it in the pod restart or the deployment restart. And then we have the deployment file itself. We have only one replica of this tool, and then the port is 9090, and then these are important configurations. Let's see what does it mean. This is in the test environment. This is not in production. So I just defined the retention time to 6 hours. It means basically after 6 hours, it's a start with every new metric available. It will delete the oldest one and then put the new one. And then there is a storage time series database, which is /Prometheus. So the directory that hosts the database itself is in this location /Prometheus, and then we have the Prometheus config file, which is /Prometheus /etc/Prometheus and Prometheus.yam. We'll load that config map into this file later, and then we attach the persistent volume and persistent volume claim. We have a service. The service is working on port 90. It's not correct, 9090. And yeah, because basically Prometheus is working on this port. And then we have an ingress here to be able to access the Prometheus interface itself. Let's apply it in our cluster and see what happens. Sorry, I didn't save it. So let's see, what do we have here? What do we have here? Container creating and container running. So I should be able to access the Prometheus interface itself from this URL. Let's go back to browser quickly. And then there you go. This is the Prometheus we just deployed in our cluster. Now let's go back to the configuration and see what do we have there. Okay, for the configuration part, as you can see, we have a global configuration, which basically means it should be applied over the whole scope of configuration file, except for the jobs or targets that directly overwrite these values. So we define a scrape interval as 15 seconds, as you can see here. For the alerting part, I think we didn't create any role file, so basically it will be skipped. And then for the scrape configs, as you can see, we have jobs here, And the first job we have is Prometheus with the name of Prometheus, and the target is localhost port 9090. So basically this job is responsible to fetch the metrics from the Prometheus application itself. Now let's see what do we have inside the Prometheus and map it with this configuration. Going back to browser, and then we go to status and then targets, and as you can see, Prometheus is the target here, right? And the state is up. So this is the target that we already created. And basically in Prometheus itself, I have to be able to get all the metrics related to Prometheus here. Let's add other targets to Prometheus configuration in a way that we start fetching metrics from all the components available inside Kubernetes cluster. Let's go back to the configuration and extend the configuration in a way that Prometheus start targeting the Kubernetes itself and detect the services, detect the nodes, and fetch the metrics related to nodes and all the metrics available inside Kubernetes cluster. Let's go back there. So then the first thing we need to do is basically adding a service account. Why? Because think about the process that we are going through. We want to allow Prometheus to start communicating with Kubernetes directly and fetch the metrics from Kubernetes API server and kubelets. And because of that, we need to define permissions, cluster role binding, and attach them to the service account. Let's do it quickly. So what do we have here? We created a service account, namely Prometheus, inside DevOps tools, which namespace, which is the namespace that Prometheus already deployed in. And then we have a cluster role. Inside cluster role, we basically provide the verbs of get, list, and watch for the resources, nodes, node proxies, node metrics, services, endpoints, and pods. Basically everything, almost everything inside Kubernetes. And then we have a cluster role binding, which is responsible to bind the cluster role we defined to the service account we defined. And this mapping can be found here. And then in the config map, what I have to do is add some configuration to instruct Prometheus to start communicating with Kubelet, cAdvisor, Kubernetes API server, and Kubernetes service discovery. Let's see how we can achieve it. Okay. We added the new job with the title of kubelet, and the configuration for this is role we set as node and a schema as HTTPS, and we refer to the certification file that is created out of the service account we recently created. It is stored inside the pod in the location of /var run secrets Kubernetes and service account certificate. And I just keep insecure script verify as true because I am working in my home lab. And then we have another job for Kubernetes node cAdvisor. We override the script interval here just to see how we can override this and change from 15 seconds to 10 seconds. And then quite the same, just relabeling the metrics it gets, and the created services, which is responsible to, let's say, discover all the services attached to the endpoints inside Kubernetes environment. And yeah, that's pretty much of it. Let's save it. Because it is the config map, I have to redeploy the deployments so that config map should be can be applied. Let's do it. Prometheus. And then redeploy it again. Let's check the pods available here. Okay, it's running. No problem so far. Let's get the logs here. Okay. We have some errors here, as you can see. Let me just stop it. Yes, I understand. Actually, it is forbidden. The pod is forbidden to, yeah. The point is that for some reason, pod is not allowed to fetch those metrics. Let's go back quickly to the Prometheus dashboard. It's a good example to see what we can see there. In the Prometheus dashboard, we go to the targets again, give it a refresh, and you can see even the jobs we defined is not available here. So I think I made a mistake. Let's go back to the VS Code and go through the configuration we created. Okay. There is a service account, the namespace is correct, and service account binding is correct as well. And the config map is okay, because if we made an incorrect configuration file, Prometheus failed to start, but it's already working, it's up and running. And then inside the deployment, yes, this is our mistake actually. We created a service account for Prometheus, but I forgot to assign this service account to this deployment. So basically this deployment goes for the default service account available in the namespace. And that's not the service account we allowed it to, we provide sufficient permission to fetch the metrics. What I have to do is create the service account name here. And service account name is let's say Prometheus, and then redeploy it. Delete, and then apply it. Get PO. Let's say and yeah, the good news is the errors are gone. Let's go back to the Prometheus dashboard. And then by refreshing the targets here, yeah, we see that we have endpoints available here, both kubelet and the CA advisor we defined in the configuration file, but the status is down, and the error message is HTTP server okay. This is the unauthorized code. So this is unauthorized code. We have to go back to the configuration file and see what we missed there. Let's go back there quickly. Okay. For example, in the kubelet, where is the job for kubelet? There it is. Yeah, this is the TLS config, which is okay, but where is the token? Okay, we did not provide the token. So think about what's happening inside Prometheus. Prometheus basically starts, let's think about it like curling the targets with some authorization header so that the endpoints can authorize the request and response to it, right? This is the part that we have problem with it. And how does this authentication mechanism works? It's based on the tokens available inside the HTTP header. I forgot to provide the token here. So that's the reason that the endpoint starts responding, you are not authorized to fetch these metrics. Let's add it quickly. Okay, this is a bearer token. Basically this bearer tokens is out of the service account we created, right? It handles all by Kubernetes itself. The only thing that we have to do is address this token to the configuration file. Where is the second? There is another job here. Let's say, where is it? This is kubelet. This is another job, sorry. And then this is kubelet. Let's save it, redeploy everything. And then go back to the browser. Let's give this page a refresh and see if it is working this time or not. Yeah, one of them is up. Hopefully the rest of them should be up as well. Yeah, perfect. So basically, we just managed to address all the we just managed to add the kubelet job and C advisor job here to pull some metrics. Let's see what are those metrics here. So for example, I should have metrics related to containers. Let's name container. As you can see, yeah, there are metrics here, and then if I want to see it in a graph, I can provide a graph out of it. Prometheus is just up, so this is the reason that we have such a thing. And as you can see, I can select whatever I want here, so I can see only the chart related to that parameter, and then I can filter on of the and then I can filter them based on the labels available here. So for example, let's make it a little bit bigger. So for example, where is the pod name? Yeah, there is a pod name, for example. So if I want to see all the metrics related to this part, what I have to do is pod equal to, let's say, this. And then all the metrics available for that specific part can be achieved here. As you can see, Prometheus has already provided a dashboard that we can visualize the data there, right? But it's not rich enough. It's very simple. Basically, because Prometheus is not responsible to visualizing those data. Prometheus is only responsible to pull the data and then collect it and then provide the data to another tool for visualizing. And the other tool that we are going to cover to visualize all the fetched data is Grafana. In the next video, we will also deploy a Grafana inside our cluster, connect it to this Prometheus, and start visualizing all the data we just fetched from the Kubernetes and its deployment. If you find this video useful, please hit the like button and do subscribe, and just share the links with your friends or colleagues who you think might be useful for them as well. See you in another video.